Good day, dear friends. I'm Mark Zhukovsky. I'm Associated Professor of Department of Information System of Economics at Altai State Technical University. And I would like to present you our course in computational economics and a special course about forecasting in economics. I'll be your instructor for this course. In this course, we will learn how to visualize time series in order to discover the useful information we need in forecasting. We also consider some very simple forecasting methods, some intermediate level methods, such as exponential smoothing and ARIMA models, as well as some more advanced methods. So we begin with forecasting introduction. What we'll learn in deep: exploring and visualizing time series, simple benchmark methods for forecasting, exponential smoothing and ARIMA models, advanced forecasting methods. We also will speak about measuring forecasting accuracy and choosing the best method for forecasting. Here you will see examples of excellent forecast. For example, 1943, Thomas Watson, IBM CEO, the most famous phrase about, I think there is a world market for maybe 5 computers. Maybe 5 computers. It's about personal computers. Thomas J. Watson was the man who owned the most knowledge about computers in this time. But he thought that there is a world market for maybe 5 computers. The next great phrase about forecasting is a phrase from Popular Mechanics, one of the most famous journal about computers. In that time, 1949, computers in the future may weigh no more than 1.5 tons. It's very funny for today, but they thought about it. And one of the most amazing phrases about forecasting in computer era: there is no reason anyone would want computer in their home. It's phrase of Ken Olsen, president of very amazing, famous and experienced firm in computer making. It's firm DEC, Digital Equipment Corporation, 1977. In this year, we see the start of Apple and Microsoft, and well, where is DEC now? The famous songs of modern talking. DEC is now in the middle of nowhere, but Microsoft and Apple is still alive. Can we predict? The predictability of an event depends on several factors, including how well we understand the factors that affect it, how much data do we have, whether forecast can affect the process we are trying to predict. For example, forecast of electricity demand can be very accurate because all 3 conditions are usually feasible. Demand for electricity is largely related to temperature and doesn't fluctuate very much depending on the calendar, holidays and the economic condition. Provided we have a sufficient history of data of electricity demand and weather condition, and we will have skills to develop a good model linking electricity demand and key variables, and forecast can be surprisingly accurate. On the other hand, let's speak about exchange rate. When forecasting the exchange rate, only one the condition is met. There is a lot of data available. However, we have a very limited understanding of the factors that affect exchange rate, and exchange rate forecasts have direct impact from rates themselves. If a bunch of analysts write that the rate will rise, then people will immediately adjust the price they are willing to pay. And voila, the price changes. In a sense, exchange rates are the product of their forecast. This is an example of the efficient market hypothesis. So, The first thing to do in any data analysis task is to plot the data. Graphs enable many features of the data to be visualized, including patterns, unusual observation, outliers, and change over time. The features that are seen in plots of the data must then be incorporated as far as possible into forecasted method to be used. Now I will show you how important is visual presentation. In our lab works on this course, we will use the most amazing, to my mind, very sophisticated programming language R. Only one English letter. But this programming language is very sophisticated and need to do our lab works. And for example, we will see what we can do in R for visual presentation. For example, we will see now so-called scatter plot. Scatter plot displays the relationship between two numerical variables. Each dot represents an observation. Their position on the x horizontal and y vertical axis represents the values of two variables. Now you can see the work of plot function, which allow to build a scatter plot. And to the right you will see the plot, and below you can see the source code. You see that source code is very tiny but very powerful. So the next it's magic of ggplot2. It's a magic library for R, and this library able to map a variable to marker features. Here you will see the marker color depends on its value in the field called species in the input data frame. And below you can see the tiny source code to make this amazing plot. The next, you can build, for example, many distribution and correlation diagram. For example, some function allow to write text on the fore margin of current figure region or one of the outer margin of the device region. Here the figure is first split thanks to inner function of R, then only one title is added and centered using some function of R. For example, its function mText. One of the amazing features of R is packages which enable to use many features for maps visualization. For example, the leaflet R package are a wrapper for JavaScript leaflet library. It allows to build stunning and interactive maps in a minute with R. Maps can be exported and standalone HTML files or be embedded in a R Markdown file or a Shiny application. All maps which is created by these packages is interactive, and we can do with them many interesting things. For example, of one of these interesting things, it's map transformation. For example, you will see another look on the US population. It's the image of states of United States of America related to the population. That is, area is dedicated to the population. And you will see how unusual is the map of United States of America. On the next slide, you can see the nice example of interactive capacity of R. It's a cartogram package which can build a map in which the geometry of regions is distorted in order to convey the information of an alternate variable. The region area will be inflated or deflated according to its numeric value. For example, you will see the map of Africa, which we see population per country in 2005 according to the population. And finally, I can show you the animated presentation, which can be built only from R. It's so-called GG animate package, allow to build animated chart using ggplot2 syntax directly from R. This post show how to apply it to bubble chart, and I'll show you an evolution in time of two variables, life expectancy versus GDP per capita during timeline from 1952 to 2005. So, dear students, our course will help you to make a beautiful presentation in the field of economics. And we will provide not only the deep knowledge of computational methods of economics, computational methods in forecasting, and also we provide the way to make the perfect presentation of your work. Thank you.